Good evening, members. I hope all is well. Your side. We have taken long without chatting, sharing few knowledge we have. But I do appreciate the constant engagement that I see from you guys, Tala, Alfred, Jimmy, and even I saw Derek. Yeah, I think this post I'm giving here is in relation to, I think, was it Derek or someone who said he spent close to a year without doing a design of successful design of Pier section or girder. I will using Midas. I tried to model two similar support system, Pier column with a Pier cap, and then a Pier column single, or what they call Pier wall. But Pier wall is when the width is exceeding 6 meters, and then columns I think about 6 meters. You can confirm what qualifies to be a column and what qualifies to be a wall. Yeah, so this is our pier cap, which is 2.4 meter wide, and then this is a tapering part with about 1.2, and our support is about 2 meters. So as usual, I did material, and I did material definition. And I'm using a cylinder strength of 30 and compressive of 37. Then the sections is where I had to define the pier cap, which is the central one here. This central one here is the 2 meter depth. Then tapers 1.2. We said look at the tapering section. Even the same applies here. These columns, I think they're about 6 meters apart. This is about 14 meters, reflecting a bit of some of this usual deck width that we consider, which is 7 meter carriageway, and then you have 1.5 shoulders on either side, and then you have walkways. Walkways could be about 2 meters, giving you 14 or 13, depending on the shoulders and then also the walkways. So basically this is how sections are derived. And then pier column, I think we have this is the type, and then we also have the circular one, that is the pier column 1 type. This is the one which we have here. Yeah, so what I did here, I used the same view to generate 2 models. Midas allow simultaneous modeling and analysis, basic analysis. You model this and model that separate, but you can run the analysis same time. Then for the tapering system, this is how it appears. Depending on which side, if you are starting from the left here, moving towards this support, so it is left to right, then I think the left would be the 1.2 meter depth, and then the width is the width become 2.4. But if you are moving from right to, if you are moving from left to right on this side, so you start with the 2 meter depth, 2.4 meter width, and then this second one, the I and J. So normally the first is the I, and the J is our 1.2 and 2.4. This is how you do your tapering system. But of course, when you're about to taper it, you have to do this. You use this command or taper section group. That is how you can easily get this and handle that. The loading, after actually modeling this, then we have this could be pile caps, but for demonstration purposes, I basically I stopped at the pier because we want to see if we can design this section. How do we design this section of the pier cap, and then how do we design the circular one, and how do we design this one? So you can you're going to see the first step is basically after doing all this, you run your analysis. After running the analysis, after loading, I think we do the boundary condition, and then now there's something here you need to take note, you guys. This part here, if I remove this the solid part, this if you don't simulate this, because this wall is from this point up to that point, it means the moment at this point tend to be higher at this point and come and narrows to zero here. Here is more or less no moment compressed because it is all one solid member, and here if you leave it, that means that it will be cantilever with high moment at this point in the center, which is not true in service. So that's how you can do the spring constant, like a point spring, and then you fix it so that now you will see the output. So when we run a model, so I should now be able to view the result, and then I look at my bending moment. That is what normally is there. That's how it's supposed to appear here. So you can see over this support you have stresses that you cannot have a moment going up here, because the whole of this is like one deep wall here, monolithical with the pier cap. So this is it. So your worst pier, what your worst moment should be away by 3 meters. That's the moment you use for design. That means if you allow this part not to have this, I'm going to remove it and demonstrate that. Let me delete it because you may not see what I'm meaning. So I run again. Oh, thank you very much. And then I go back to moment. I want you to view this different. So what am I saying? This is now, if you pick this moment for design, ladies and gentlemen, I'll be lying. It will be very, very, very expensive design, because now this is a very, and yet here, the whole of this area 3 meters away is what? Is the solid column or wall. So that means that at this point where this yellow ends is actually the moment you could actually pick to use. But again, if I look at the value, you may find this moment is not the same. So let us say I am 2.7, 2.25. This is where 3 is. So that means my moment for design, I would pick, let me say 911. Then even the same 911, which is this side. So here is okay, because this one you have 2 columns and you have that. So is it true if now this one, and then here the moment now I would pick is 2,496. This is a 4, if you look at 24 and 1,000, that's a 2.4 times what you need. So that is something we need to take note of. Basically, that is that. Of course, conservatively you can take it if you have the money. No one is going to do a bit of quality assurance. Definitely you can apply, do that, and then you reduce moment. You reduce as we get along out here, which at the end of it told you, but that is not true representation, because this is not a point load. You have this. So I'm going to go back here and then introduce I go back to boundary condition point spring, and I just fix this one first for purposes of getting the right model, and also something that is true representation. Then I run analysis. Now when I view my moment, will it give me the same we looked at? So what is the value of this moment? Let me look at the value. So you can see this is about 700. So if you 700, actually it was about 700. I move stubbornly to about 900. So you can see that this is now, that means if you use the other approach, you use the moment which is at the edge where the column ends. So basically that's what needs to be done. Okay, fine. So having done all this, what we wanted to look at is how do we do the design. So you have to first look at the model. We did the combination is here, and I did on a live load, the date load, and the self weight. I did not go into the the temperature and all, but the live load includes the tractive force or the braking force. So Actually, I have the ultimate limit state here. And then yeah, basically that's how the whole thing is. So at the end of it all, if you were to look at the design, I would the design here, if you go to the design, this design procedure all given to you here. You follow this, but most important is make sure that you modify this concrete to have all the concrete reinforcement specified, everything. And then you come to you look at the serviceability. I think for this case we have done the dead load quasi and then the characteristics. Well, there was no any other like additional live load and the rest, so the frequency is not there. So what we do, this one is where you do the beam section is where you come and make sure you specify all the requirements. Here stirrup, you do your the stirrup is given here, you enter it, then you go to the beam section data checking, you make sure you check the reinforcement. You first specify, because it's iterative, you specify reinforcement you're going to do and make sure this I node, the model, the middle and the Z node not all are specified. Then when you do that, so it means that is that. Then this is for the beam. For the column, you come to the column beam here, column. This plate beam and the plate column is for walls, the abutment walls and box culvert. So for column section, these are the one you see. So this is for the other pier for this member, and then circular one are for these two. So this is for the circular one. All have been done. You specify, and then you let me see how we did that column section for design. This is the reinforcement you have to specify. They're all here. You start with the stirrup, and then here you specify reinforcement. Then for the circular one also, you make sure you know the circumference, which is pi d, and then you divide and get, if you're spacing your reinforcement by 150 or 100, you can see how many there are. You put, if you run a design it may fail, but iteratively you should be able to do that. So at the end of it all, now I come down here and then I say I need plate beam. Okay, why is it showing me that? Let me see. I haven't not done anything. What is happening? Is it run design? Let me see. Let me first see if my column checking also. For column, I think for column we are done. So for column, this is where the column is. You have all these checks have been done. The checks against stress, checks against shear force resistance, I think. Then the PM interactive diagrams are all here. The axial forces and moment resistance checks are all given here. The applied loads are also here, and then the design and whatever you have done, and the reinforcement you specified on the number. Now here you can optimize. If 40 P32s are passing with a certain factor of 0.23, that one, then you have to maybe on a 26, that would be good enough. So that is what you could do with this column. I need the one for, what about the let me check the Pier column again. I think there's one more. Okay, if I do this, I do the graphic, but about it's only one. I wanted also to have to see the one for, this is only for circular one. I want to look at why did the beam, let me look at the beam here. This beam, we have all that specified. Then we have the beam for checking. I think we did what we could. And then serviceability. And then let me see, let me put that. Frequent, I think we don't have it, we're specifying. Why is it saying Okay, it has passed. So for the beam here, so this is what is giving. So you find it gives you also the same thing for the pier cap. You have the bending moment capacity checks, the positive moment, the negative, the shear capacity, all been done here. So you should be able to do that. Now, one thing you need to take note of, this doesn't design for the tapering section. You should be the one to specify or model it. You can do averaging, so that you are able to calculate to get what you think will give you the. So here, I think if you do all, it should be okay. Fine, they are all there. Okay, so this is briefly the section. I want to look at this design of this pier. I don't okay, fine, let me go back here at the pier column section for design. I think the second one. No, I want this one. Why is it not appearing in my why is it not appearing? So I want to get the column. I forgot this here, pier column. That. So since this is the one, thank you. So basically this section is also given, and then it gives you all this calculation. You can actually see that this one, the PM interactive diagram is very close to this. That means you can see that just this reinforcement indicating is too much. 6 of P32 is too much. You need to do and then reduce it until you it. So you can see the ratios basically it is 0.01 something. That means it's too much. This has to be adjusted. So I think you can do the design. Now we can also do another checks. Let me see if time can allow. If you come to if I come to now, you have to I have to do the setting first. Where is my display setting? I need 100. It become very small, which is but still okay. So if I come to my thing here, let me first put my spec to LVC. You can do this design using the general section design. Now the general section design, I come to tools, I come to general section properties. General section design is here. Now if I have this general section design, I make sure I link this module, connect it. Now I've linked the module with the general section. So when I go back now here, I want to design this member. So I just come and highlight the member. Like sorry, this is let's pick two. Let me do the lower one. So this member is number 1. So when I go to general section design, number 1 has been picked. So I come to I think file. No. I think I'm supposed to import here. So these are the load factor. I can put all, and then I say yes. So you see this section I already specified reinforcement. If I had not specified reinforcement, I would be the one to come and specify the reinforcement using this this area. Since this is like you're adding these bars, I would do the points, or I would do the lines. I would do now. If you do perimeter, means you just calculate like a circular one. I will just specify. I will try for there, and you look for a circular section. You do that. Now for here, you would do this reinforcement here using the line. But I think here it has also given you the point, so it's like added. But I would also do the line. I would come in here and I specify the bar size are given, and then I would be the one to pick it. Click one here. If there's 17, I put here like, if I put like 14, I put n bar. So I will just do that. What I'm fearing, I don't want to do, because I want to make sure we run it just to demonstrate. So but you come here. This is where you specify that. Sorry, it has started picking. So you do close it, fine. But this is where you come. And once you have done that, then you come and do your design. If you have specified all the reinforcement, you just say design this section, and I can actually put it here that our pier column maybe 2. Then I say save. So it's going to run a design, and you see how you get the different interface of this design. So this is how the design. So this is how you do a general section design. It gives you what we call, this is the PM curve, the P and the M. So you have to come here, the load combination, and you see it's giving you the reinforcement so close to 0. That means the reinforcement we have specified there in this section, if we could go back to the section, it's very many, so that need to be revised. Now if you come to these and then you also view, this is the MYMZ, you see the moment is more or less 0, the reinforcement more or less 0 in here. The things are very, so we have over design of that. Though don't worry about this, because this was arbitrary value, and then all this load combination, they're all here. Then the 3D curve, you can see in the ratio of P, My or Mz is like negligible. So that is where the engineer goes back and then begin to review his section. Then we can also look at what they call the taken long without doing this methods. There is now where we view the section and stress contour. No, it is somewhere here. Select all, ultimate, select. So where do I go here? This is our 3D. Okay, it is here. The stress contour is here. Ultimate section. So if I want to not the stress, I want the diagram. So this is how my diagram will look like, and then this is the stress, this is the force, this is the strain. So you are able to, you can see, you can actually look at all this. So this you check, and even the table is given here. So this table of forces and the coordinate are all given. So you can see whether this stress is exceeding the reinforcement stress or not. You look at, check all the stresses. But from here, so here, this way you can also generate a report. You can generate a report. You put a report in here. This report goes to where we have done the saving. So this would be the design. This would be the design. So this would be the design using the general section design approach. You don't from the model, you have to ask. So sometimes you may find your computer, your software may not have this component. So you communicate to these guys in the headquarters in India, and they can link up with you and your computer, and they install it for you. So I can design any section using this. I do model, do everything, then you do a link between the general section design and that. For those who are very good at this thing, you can also draw it. You have seen it as that drawing interface. So this is now printing Excel report for you to be able to generate a report. Otherwise, it's actually done. So that shouldn't be a worry. Derek and your colleagues, you can design. Of course, I agree some sections are difficult to design using Midas, especially if you are doing those post-tension precasts. I gather, yeah, it's a bit tricky. You become difficult even if you go to even if you come to this general section. If you have seen carefully, I think Midas under more of rectangular sections and a bit of that section of the octagonal section, like the one of the pier. That's what I saw. But if not, normally you can also do what they call an equivalent section. So you convert your irregular shape, which is not in the library of the software, for design, and then you come up with a rectangular similarity, whereby you are able to do a model using this software, and you're able to get something that will not be off the limits. Okay, so basically this one is delaying, but of course if it runs, it will give you that, and it is saved. You just then your view. But this is exactly as simple as it is. Just take note and be happy that it is possible. Only thing is, make sure you're consistent with your model and other things. So basically that is a quick check that I wanted to do. Of course, this is delaying. I wanted also to do for a column. Let me see if I can just try. It's not even closed. I would have closed this. Okay, I would have closed this. So it has gone. So what I wanted was to do for us the one for a circular column. I would do that. That is the number 45. Then I come back to general stuff. It has even given. I import it and make sure I can specify one or two. The thing. There we are. Now normally we import without reinforcement, but because here I already specified using the other approach of reinforced concrete design component. So here now this is where I'm telling it is too much. You're going to view. So let me go straight to the design, because everything is already given, so that you are able to see that actually so when you look at least here is not there. See, Alice is moving. The PM curve still within the curve. This is the limit. So beyond which the member has failed. So this is fine. So if you go to MY and MZ, put the load combination is still within, and the 3D, they are 0.7. Yeah, it's fine. But somewhere you can find 0.2 depending on the moment of inertia and then the distribution of stresses. Some are more and some are less, but at least all is okay. So when you go to the stress, you see for circular stuff, this is what we would have: display, ultimate, and then I want to look at the diagram. This is exactly what you would look at. So this is basically what we go through. You should not worry. This is how you handle this thing. Okay, fine. So neutral axis and the rest of it. So basically that's as brief as we can when you want to design. So there are two areas. You can still use the model it, analyze it, design, specify this section, run a design, or you use a general section design separate, but you link the module. You have seen you have to link it. So basically that is that. Thank you so much. I hope this will clarify. Derek?